All right, let's jump right in. Today, we're tearing down this source documentation behind what is honestly one of the biggest bottlenecks in the modern digital economy. And that is, how do we actually share and, more importantly, monetize data securely, fairly, and at a massive scale? Well, we're looking at the Codatta Access Gateway and Metering Framework to answer exactly that. You can think of this as the ultimate command center for data. It's this highly secure, totally automated system that dictates exactly who gets to see what, under what conditions, and then, this is the best part, how that usage translates directly into accurate, auditable royalties. So if you've ever wondered how the back end of the future data economy actually functions under the hood, you are definitely in the right place.
Okay, so here is our roadmap for today, which actually perfectly mirrors the journey of a single data request moving through the Codatta system. We've got 1, the Access Gateway Framework, 2, evaluating the policy, 3, obligations and secure serving, 4, metering and royalties, and finally, 5, audits and system invariance. Let's get to it.
Starting off with Section 1, the Access Gateway Framework, setting the stage.
To really wrap your head around what this framework does, I want you to imagine two people. Imagine a famously strict bouncer at the door of an exclusive club and a hyper-meticulous accountant sitting at a ledger. That brings us to our fundamental question here. Who can access what, and how does that turn into royalties? See, when a request comes in, our bouncer decides who gets past the velvet rope, exactly which version of a dataset they're allowed to read, how much they can read, and under what specific conditions. And then, once they're inside, the accountant, which is the metering module, turns those permitted reads into signed, undeniable usage events. And those events, those are the absolute lifeblood that will eventually drive billing and creator payouts. So let's look at the pipeline step by step, taking a client request all the way to an auditable billing event. Step 1 is the request. A client knocks on the door and they bring their identity, their license, and their purpose for wanting the data. Step 2 is the decision. The Access Gateway runs a really strict policy check. It might say deny and actually explain why, or it might say allow. Step 3 is serve. The data gets pulled from storage or ideally a secure trusted execution environment, or a TEE. And then finally, step 4 is meter. This emits a signed version-pinned event that gets sent straight over to the royalty engine and the audit log. It's just a totally seamless automated flow from start to finish. All right, moving right along to Section 2, evaluating the policy, the bouncer's checklist. Now, before a single byte of data is ever served, Codatta evaluates a really precise set of rules. It basically breaks down these attribute-based policies into 4 crystal-clear buckets. First, we have the principal. Who's asking? The system is going to check their wallet or decentralized ID, their verification level, like KYC, and the reputation tier. Second, the resource. What exactly do they want? It looks at the specific dataset ID, the exact version, and its sensitivity class. Third is the action. How do they want to use it? Are they just reading it, exporting it, streaming it? And fourth is the context. This checks the region, the purpose, is this for research or is it for commercial use, along with their current quota and license status. Literally every single request has to pass this rigorous 4-part matrix. No exceptions. Which brings us to Section 3, obligations and secure serving. The nuance of yes. Because in the Codatta framework, decision-making is way more sophisticated than just a simple binary yes or no. I mean, sure, you have your standard decisions, you've got an absolute allow or an explainable deny, where the system tells you exactly why you just got rejected. But the real magic, that happens with an allow with obligations. The gateway might say, yes, you can access this data, but I'm only going to give you an aggregated version. Or, yes, but you can only process it inside a secure enclave. It dynamically enforces these conditions at the exact moment of access. And this perfectly sets up a truly brilliant licensing concept, TNPL, or Train Now, Pay Later. Look, let's be real for a second. Most AI developers are just burning through compute money long before they ever see a single dime of profit. This model completely bridges that gap. Instead of needing massive upfront capital just to access high-quality data sets to train a model, builders can access the data now and accrue deferred obligations. They only settle the bill when their project actually generates revenue. It's a real game changer because it completely lowers the barrier to entry for innovation while still totally guaranteeing that the original data creators will get paid. But you're probably wondering, how do we actually ensure privacy is maintained when access is granted? Well, in practice, secure serving leans on a few key mechanisms. First up is minimal disclosure. The system decrypts only the absolutely necessary bytes, and it often prefers to process them in a secure TE. Next is selective disclosure. This means requiring verifiable credentials instead of just sucking up raw personally identifiable information. Then we have masking and aggregation. So the gateway can redact specific fields before the data ever reaches the user, or it might just return aggregated stats. And finally, sampling. This allows the system to serve representative slices of the data for exploration. So users can kind of test the waters, but full access still requires higher policy tiers or, actual payment. All right, on to Section 4, metering and royalties. The accountant takes over. So our bouncer has done their job and granted secure access. Now, the accountant steps in to meticulously log the activity. Let's look at the anatomy of a metering event, because every single permitted read generates one of these highly detailed, cryptographically signed records. Honestly, think of this as the ultimate receipt. It tracks the who, securely linking the requester to their payment account. The what, specifying the exact dataset and version. The how much, measuring rows, gigabytes, or compute seconds. The when, capturing the precise timestamp. Crucially, it logs why allowed, recording the exact policy rule ID and the obligations that permitted the action. It logs how priced, noting the specific valuation config version used, and lastly, the proofs, locking the whole thing down with a gateway signature and a unique event ID. This isn't just a log. It is undeniable cryptographic proof of usage.
And all that meticulous detail leads us to this one foundational truth. Because events, ownership, and valuation are versioned, payouts are deterministic and explainable. Pinning everything to a specific version, that is the secret sauce that feeds the royalty engine. If a policy changes tomorrow, or say a dataset gets updated next week, it doesn't matter for today's transaction. Today's transaction is locked to today's versions, period. This guarantees absolute fairness for creators, ensuring that absolutely no one can retroactively go back and alter the math.
And that brings us to our final section, Section 5, Audits and System Invariance, Rock-Solid Guarantees. Here is where we look at the absolute, unchangeable rules that make this entire framework trustworthy. I love this quote from the source docs because it perfectly highlights the uncompromising security of the system. Tamper evident. Events and logs are signed. Disputes use reserves until resolved. Every single action leaves an indelible, verifiable mark. You literally cannot sneak through the gateway without generating a signed log. And if a dispute does pop up, the system is designed to hold funds in reserve until the cryptographic proofs settle the argument once and for all. These 4 invariants right here ensure that the system can perfectly replay any event and arrive at the exact same payout. First, it's explainable. The system never just says, computer says no. It cites the exact rule. Second, it's deterministic. If you input the exact same request, policy, and dataset version, you're going to get the exact same decision every single time. No surprises. Third, it's traceable. Every byte served can be traced straight back to its origin. And finally, as we just discussed, it is tamper evident, fully sealed with cryptography, meaning the audit trail is completely flawless. So I want to leave you with this thought. If every byte of access data is deterministically tracked, priced, and audited automatically, how will this transparent gateway redefine the future of the digital economy? The Codatta framework really shows us a world where data creators are fairly, undeniably compensated, and builders get secure, flexible access to the exact information they need to build the future. That is a massive paradigm shift. Thank you so much for joining me for this explainer. I hope this gave you a really clear picture of the incredible machinery running behind the scenes here. Until next time, keep exploring.